Okay, welcome to day 16 of AOC 2023. This was a cool little puzzle. It was simple, but it was also it was simple, but it was also just I don't know. If you're iterating over this, doing this in an iterative approach, 4x and y, blah blah blah. If you're doing it that approach, then there's just a lot of code to write, a lot of cases to write in. There's probably a much more efficient way to write this. Not necessarily efficient running, or probably a more efficient way of running it, but just less code that you could write, I'm sure. So let's dive in. So we're going through. So we start from, in this particular problem, we want to start from the top left, and we want to move to the right. And we have empty spaces as dots. We have mirrors as / and backslash. And we have splitters as a pipe and a hyphen. So, if the pipe enters in the top left corner, moving from the left, heading to the right, its behavior depends on what it encounters as it moves. If the beam enters an empty space, it continues in the same direction. If the beam encounters a mirror, the beam is reflected 90 degrees depending on the angle of the mirror. For instance, a rightward moving beam that encounters a / mirror would then continue upwards in the mirror's column, while a rightward moving beam that encounters a backslash would then continue downwards in the mirror's column. If a beam encounters the pointy end of a splitter, the beam passes through the splitter as if it were an empty space. So if we encounter a pipe and we're going up or down, then we're just going to carry on going up or down. And horizontal, if we're going left to right and we encounter a hyphen, we carry on going the same direction. If the beam encounters the flat side of a splitter, so if we're going left to right and we encounter a pipe, it's then split into two beams going in each direction of the splitter's pointy ends. For instance, a rightward moving beam that encounters a pipe would split into two beams, one that goes up and one that goes down. Beams do not interact with other beams. A tile can have as many beams passing through it at the same time. The tile is energized if that tile has at least one beam passing through it, reflect on it, or split from it. In the example above, here's how the beam of light bounces around the contraption. So we go in from the left. We firstly hit a splitter, so we go all the way down. And we hit a splitter and we go left and right. So on and so forth. Right? We follow this round. Beams are only shown on the empty tiles. Arrows indicate the direction of the beam. If a tile contains beams moving in multiple directions, the number of the distinct directions is shown instead. Here is the same diagram, but instead of only showing whether a tile is energized or not, instead it just shows whether it's energized or not. Ultimately, in this example, 46 tiles become energized. Your light isn't energizing enough tiles to produce lava. To debug the contraption, you need to start by analyzing the current situation with the beam, starting in the top left, heading right. How many tiles end up being energized? So we have 46 as the test input. Mine was 7608. So because we've got backslashes in here, I've had to use a raw string. So let's see how we do with this one. Okay, so what we want to do is firstly split into a grid. So let's say grid is equal to string dot split lines. we want to keep track of the scene, points. So maybe let's make a variable up here called point, and this will be a tuple of an int and an int. And let's just import that up here as well, from typing import tuple. Let's also import set while we're at it as well, and probably a list, just for the sake of it, just in case we need them. Hint, we do. So we have these coming in here. So let's make a scene set, which is going to be a set. We're going to have the points in there, and it's going to be so we want to keep track of both the direction and the point. So the direction I'm just going to represent as a string. So if we have a tuple of a point and a string, and we'll just set that to equal to set. Nice one. Right, so we have a queue of things that we want to go through, and this is going to be a list of the same thing. So a list of a tuple of a point and a string. And initially, we're just going to start with the first. So we want a list of tuples. In the first entry, we want to have the first point, and we want to move to the right. So that's going to be our queue initially, and we're just going to process that and then add to this queue constantly, and we're just going to just simply make a while loop and process the queue that way. So then let's then start going through it. So while queue, so while we have something in the queue, the current and the direction is equal to queue.pop. If the current and the direction is in scene, we are then going to just continue. Just move on. Because this pops it out of the queue, and we're not adding it back into the queue, eventually the queue will deplete. So, yeah, we have the direction that we're going in, and the current, so we pop that out. Right, so then if the current is less than 0, or the current 0 is greater than or equal to the length of the grid, because all we're going to be doing is adding everything to here, and then we'll check it within to see if check it as we're processing it to see if we can do anything with it or not. If we can't do anything with it, we'll just carry on, rather than doing all the validation every time we add something in. We're just going to add it and then process it later. Or the current is less than 0, or the current one is greater than or equal to the length of grid 0. If any of that is true, that needs to go there. If any of that is true, then we are simply going to oh, that was almost bad. We're then going to continue. Cool. So now we are processing something we have not yet processed, and it's valid. So we're going to say scene.add, and we are going to add the current and the direction. We are then going to say the character is equal to the grid of current 0. In fact, let's do row column. Let's do it like that. This may work. So if the row is less than this, or the row is like that, and then we want the column and column. What did I just do? Oh, okay, right, so the column is blah, blah, blah. Right, so then we want to add the row and column. And then here we want the row and the column. That work? Unexpected token. Or R. There we go. So now we have the character there. So now this is all the stuff we need to check. So this is the stuff that's painful and just takes the longest. So if the character is equal to a pipe and the direction is in either left or right, then I'm going to say q.append, and we're going to append the row -1 and the column how many we got here? So another one there, and then the direction of up. Cool. So then if we grab that, paste it down, and then we're going to say we're going to go +1. So we're just going up and down. So I've just done up, down, and then I'm doing L and R for left and right. So essentially, we carry on repeating this. So if we say yank that, paste it in there. So if the character is in, and then we want a pipe and a dot. And the direction is equal to down. Is equal to down. Then we are going to down, then we're going to carry on going down. as this is a +1. So then we want to yank this again, paste it in there. So if this is an up, then we want to carry on going up, and this is going to be a -1. Cool. And then we want to repeat this for up and down and left and right. So if we grab all of that, paste that in there, let's give it some space. So if we then have if the character is now a pipe, sorry, not a pipe, a hyphen, and the direction is in up or down, then we want to so now we're going to keep the R the same, but we're going to increase the column and go right. We're going to decrease the column and go left. If it is this, we may as well change this as well while we're at it. And the direction is left, right. Then we're going to carry on going right. Otherwise, we're going to go left and left. And instead of R+1, it's going to be C+1 and C-1. There we go. So that's those. So now we want to process the corners, those / and \\. So what we want to do with this is say if the character is equal to a, let's do the / first. So if we're going up, I said up and then typed down. So if we're going down, then q.append, and we're going to go the direction we want to go is so we're going up, so we want to keep, and we've got onto the angle, so we want to keep the row the same, but we want to increase the column because we want to now go to the right. So we're going to go row, column, and we're now going to go to the right. There we go. Yank that and then paste. So if the direction is down, then we want to go row the same, but this time we want to go to the left, so we want to go C-1. Oh yeah, I forgot to put in the +1 there. So now we have C-1. Cool. If we are going right, then we are going to do row -1, because we're going to go upwards now, keeping the column the same, and we're now going to go up. And if we're going down, if we're going left even, if we're going left, we're now going to go down. So the row is going to increase, and we're now going to go down. Cool, so that is essentially what we do with the /. We're going to do the same thing but with the / and reverse it. Reverse it. Jeez. Right, so then we're going to, so this time we want to do a /, and we want to do up, down, left, right again. So this time, instead of +1, we're going to go -1. Instead of going right, we're going to go left. Instead of left, we are going to go right, and we're going to go +1. -1, we're going to go +1, and this we're going to go -1. So this is going to be up, and this is going to be down. Going right, we're going to go down. Yeah. Cool. So that's essentially that. End of line while scanning literal. Blah. So if the raw string. Okay. Fair enough. I don't get why that happened, but fine. Okay, so we have all this. We're going to process the queue, go through all of that. So then the total is going to be equal to the length of a set. Going to make another set. So S0 for S in scene. So this will just give us all of the coordinates that we have actually seen. So if we run part 1 and part 2, we get 4 for my actual input. I don't think that's right. So let's just check my actual input. Yeah, it shouldn't be 4, it should be 7608. So what have I missed? Is there anything I have missed? So if the character is equal to this, if the character is this, we're going to do that. If the character is that and we're going down, we're going to do this, that, and we're going to go up. Then we're going to go left, we're going to go right. I think those seem fine. Those are all dealing with rows, those are all dealing with columns. This is dealing with columns because we're moving in a vertical direction. This is going with rows because we are dealing with left and right horizontal direction. Oh, I see what I've done. So that is left, right. 7608. There we go. Small little typo. So yeah, essentially all we do is we go to the next thing, we then add more into the queue. If we get to a split, we then add the left and right or the up and down for the split. When we get to an angle, we change direction. That's essentially it. So the second part of this became quite interesting. As you try to work out what might be wrong, the reindeer tugs your shirt and leads you to a nearby control panel. There's a collection of buttons that lets you align a contraption so that the beam enters from any edge tile heading away from that edge. You can choose either of the two directions for a beam if it starts in the corner. So if it starts in the top left, you can go either right or you can go down. Or in this case, if you're starting in the bottom right corner, it can either go left or upwards. So if the beam could start on any tile in the top row heading down, any tile in the bottom row heading up, any tile in the left heading right, and any tile in the right heading left. Produce lava, you need to find the configuration that energizes as many tiles as possible. In the above example, this can be achieved by starting the beam in the fourth tile from the left on the top row. Using this configuration, you get 51 energized. Find the initial beam configuration that energizes the largest number of tiles. How many tiles are energized in that configuration? So essentially, what I'm going to do, let's go to the top, let's grab everything, let's go over to part 2, and let's go to the top, let's grab everything and let's overwrite it. So this here is now going to be 51, which will give us so it's the same test input, but it's going to give us 51. So essentially we want to do the same thing lots of times. So I'm going to do the grid exactly the same. This time I'm going to make a load of start positions. So I'm going to say starts is equal to, and so we're going to have, this is all going to be 4 of the same thing, but just from a different angle. So we want to expand into this array list. We want to have the 0 and the column. So this is going to be starting at the top, the 0th row, all going down. So we want to start at the 0th row and whatever column, going down for column in range length of grid 0. Okay. Now what we want to do is do the same thing for the row with a grid with a column of 0 going to the right for every item in the grid. Let's say R in there too. So that gives us those. Now we have down and to the right covered. So now we want to go up and to the left. So if we paste this in twice, let's go up here. So what we essentially want to do with going upwards is we want to start at the length of the grid -1, whatever column, going up for column in grid 0. Doesn't really matter which row we're dealing with, but yeah. And then finally, we want to do the row and the length of the grid of 0 going to the left for the row in range grid. Cool. So that will give us all the different starting points that we could use all the way around the edge. So essentially, what we're going to do, we're then going to keep a list of all the results, and we're going to repeat this same thing for all of the different entry points. So for start in starts, then what we're going to do is we're going to grab all of this, all of that. We are then going to indent it. We then have the scene and the queue. The queue is going to be the start, because we have already said which way we're going to try going in the in this part up here. So that's just going to be the start. We just keep going over this exactly as we did before. This time, when we get to the end, I'm going to say total. So our total needs to the total here can go, and instead the total down here is going to be the length of the set in scene, and then we'll do results dot append total, and then we are going to get we're going to return the actual total is going to be the max of the results. Did I not make results? Sure, I made result. Oh, results. There we go. Cool. So essentially we do the same thing, but we just do it from every single starting point around the edge. That's essentially what we've done. We put all of those into a results list, and then we just get the maximum result from that list. So let's do part 2. Takes a while to run because they're big. We get a passing test, and we then have 8221. I'm sure there was a much more efficient way of doing this one, but yeah, that was my solution. Going over it iteratively, and then just repeating the same thing for every point on around the edge. So yeah, thanks for watching. That was day 16. I've only got one more day that I've completed so far, which is day 17, Clumsy Crucible, which was a good little puzzle, as they all have been this year. I've really enjoyed AOC this year. Excellent. Right, thanks for watching, and see you for day 17.